Okay, so we are going to talk about what we call the fundamental identities. Okay, what is an identity? Okay, a characteristic. You're talking about like your own identity. Okay. Does anyone have another way to describe an identity? Okay, let's think about something that isn't a person. Okay, let's think about what an identity would be in math. Okay, properties. What an identity is, it's something that is true. Okay, when you look at yourself in the mirror, you're looking at your own identity, right? You're looking at yourself. Okay, so what an identity is, in math, we're going to have an equation that is a true statement. Okay, so some of these you're going to be familiar with. The first ones we're going to talk about are the reciprocal identities. Okay. Our first reciprocal identity is that the sine of theta is the same as, right, 1 over the cosecant of theta. Since those are reciprocal functions, this is an identity. The sine is 1 over the cosecant, which is the same thing as the cosecant being 1 over sine theta. This is probably one that you are more familiar with, but it can work both ways. Do you agree? Okay. If the cosecant of theta is 1 over sine theta, and sine theta is 1 over cosecant of theta, what would be another reciprocal identity that you know? Okay, our secant is the same thing as 1 over cosine, and cosine is the same thing as 1 over secant. And what would our last two be? Okay, our cotangent, we take 1 divided by the tangent. Okay. Here are our 6 reciprocal identities, which you kind of already knew, because with the unit circle, okay, if I asked you for the secant of pi over 4, you would go to the x coordinate and you would flip it, right? You already kind of knew that these are the reciprocal functions of each other. Okay, so these are the identities that we're going to use. Okay. You need to know these off the top of your head. Okay, which I don't think these will be hard. All right, you already know which functions are reciprocals of each other, so these should be easy to rattle off. Okay. The next set of identities I want to go with are the quotient identities. Quotient means what? Division. We have a couple functions where we use division to get their value. Okay, so I'm going to reference our unit circle here. If we were using the unit circle and I said, hey, evaluate the tangent, how would you do that? Y divided by x. Okay. Now, what does the y coordinate stand for on the unit circle? Sine. What does the x coordinate stand for? Cosine. So, would you agree that the tangent is the same thing as sine divided by cosine, right? If the y coordinate is sine and the x coordinate is cosine, y divided by x is the same thing as sine divided by cosine. Which means our cotangent on the unit circle, how do we evaluate cotangent? Okay, we would take x divided by y, correct? Which means the same thing as cosine divided by sine. Okay, so really, you've kind of known these two as well, all right? But you've thought of tangent as y divided by x on the unit circle, okay? But we know what y and x stand for, so we can write them like this. These two you have to know off the top of your head. Pythagorean identities. What's the Pythagorean theorem? Okay, we have a right triangle, leg squared plus leg squared equals hypotenuse squared, right? So I'm going to go back to our unit circle here. And so we'll just take this right here. Okay. What's this distance right here? Okay, and square root of 3 over 2 represents what of this angle? Okay. Radical 3 over 2 represents the cosine, correct? What's this distance right here? 1/2, and that represents what of 30 degrees? The sine. And what's our hypotenuse? On the unit circle, what's our hypotenuse? 1, there we go. Okay. So we have radical 3 over 2 squared plus 1/2 squared equals 1 squared. Okay. Now I can set up a triangle like that for each of our angles on the unit circle, right? And each time, this is going to be our x value, which is cosine, right? This is going to be our y value, or our sine value of the angle, and our hypotenuse is always 1, correct? So we have the identity that sine squared plus cosine squared equals 1. Leg squared plus leg squared equals hypotenuse squared. The legs on all of those right triangles that I could draw in the unit circle are going to be the sine value and the cosine value. Our hypotenuse is always 1. Now we actually have 3 Pythagorean identities. Okay, here is the first one. As long as you know the first one, we can get to the others. Okay. You have to know sine squared plus cosine squared equals 1. Now, I'm going to come over here. Our second Pythagorean identity is 1 plus tangent squared theta is secant squared theta. Why is that an identity? Okay, I'm going to come over here. This is kind of a side note. All right, I've shown you why we have sine squared plus cosine squared equals 1. Right? Now, what I'm going to do is I am going to divide both sides by sine squared. Not sine squared. Yes, sine squared. And do cosine squared. Sorry, I wrote these in a different order. Okay, we're going to divide both sides by cosine squared. What is sine squared divided by cosine squared? What is sine divided by cosine? Okay, sine divided by cosine is tangent. All right, so this sine squared divided by cosine squared is tangent squared. What is cosine squared divided by cosine squared? 1. And what is 1 divided by cosine squared? 1 divided by cosine is the same as secant, so 1 over cosine squared is secant squared. Okay, that's how we get this second Pythagorean identity. Our third Pythagorean identity. Okay. 1 plus cotangent squared is cosecant squared. Okay? So we can do the same kind of thing. I've already shown you that sine squared plus cosine squared is 1. Okay? So what I'm going to do here is I am going to divide both sides by sine squared. What is sine squared divided by sine squared? What is cosine over sine? The same as cotangent. So cosine squared over sine squared is cotangent squared. And what is 1 over sine? Cosecant. So 1 over sine squared would be cosecant squared. So if you know this first one, you can get the second two, or you can just memorize all 3. Okay. The reciprocal identities, the quotient identities, and the Pythagorean identities you have to know off the top of your head. More than likely, not more than likely, that will be the first question on your quiz on Monday. What are the reciprocal identities? What are the quotient identities? What are the Pythagorean identities? Because if you don't know these, you can't do anything else the rest of the week. Okay? So you have to know these. Alright? Okay. I do want to talk about odd and even identities very quickly. These identities we don't use very often, but I do want to talk about them because we know what an odd and even function is algebraically and graphically. Okay, so first I want to talk about our sine graph. Our sine curve looks like this, correct? If I keep going, it looks like this. Okay. Is this an odd or even function? Let's talk about graphic properties. One is symmetric about the y-axis, one is symmetric about the origin, which is which? Odd has origin symmetry. What is this symmetric about? This is symmetric about the origin, so it is an odd function. Okay? Which means f of negative x is the same thing as negative f of x. And since cosecant is the reciprocal of this graph, it has the same properties. Let's talk about our cotangent graph. Or not our cotangent, our cosine. One period looks like that, right? I'm going to continue it to the left. This is symmetric about the y-axis, which means it is an even function, okay? Algebraically, our even functions, f of negative x, was the same thing as f of x. Okay? And since we graph the secant based on the cosine, it has the same. Okay? And then lastly, we have our tangent graph. Odd or even? It is odd. We have origin symmetry. So f of negative x is the same thing as negative f of x. And same thing with the cotangent.
Wait, for the cosine?
Uh-huh.
Would it not be?
No, because it's even.
Oh, okay.
So these I wanted to talk about. They don't pop up very often. This will not be ones that we use a lot, but I wanted to talk about the odd and even properties of a graph because it's nice to bring those back. Okay, those of you going on to calculus, these you'll see a little bit more. Okay. All right. So what are we doing with these, Mrs. Homan? Today we're going to simplify. We're going to take an algebraic trigonometric expression and we're going to simplify it down a little bit. Okay? Now what I want you to notice, in this case we have x's for angles. It doesn't matter what your angle is as long as your angle is consistent. So if they're all u's or they're all thetas or they're all x's, that doesn't matter. The properties are going to work the same. Okay? It just has to be the same variable. Okay? So I'm going to show you some tricks, what you need to look for, okay, when you're simplifying these. So here we have sine x cosine squared x minus sine x. Okay? What do you notice? Okay, and that's a good thing because that's their angle. They all have the same angle. All right? Something else. Okay, well, we have two terms here, right? We have this term minus this term. What's true about both of them? They both have a sign, okay? So what's true if we had a polynomial and they both had an x squared? What would we do? Factor, okay? Both of these have a common factor, so we can factor it out. So when I factor out a sine x, right here we're left with cosine squared x, and here we're left with 1. Good. Okay. Now, this is what I need you to notice. Okay. Anytime you see a sine squared plus cosine squared, that's a hint that it's a Pythagorean identity. Okay. Now, we can rearrange these identities to be able to use them, okay? So I want to go back to here. All the way back here, all right? Cosine squared would be the same thing as 1 minus sine squared, do you agree? Sine squared is the same thing as 1 minus cosine squared, do you agree? Anytime you see a sine squared or a cosine squared along with a 1, that could be a Pythagorean identity. Now, it has to lay out nicely, okay? But when you see this right here, you should think, I need to look at my Pythagorean identities because I see that cosine squared minus 1, okay? So when you look at your Pythagorean identity, cosine squared minus 1 is the same as what? Look at your Pythagorean identity. What cosine squared minus 1 would be the same as? Okay, over here on the board. What's our identity? Sine squared plus cosine squared equals 1, right? I see a cosine squared and a 1 right here, right? So I'm going to do this. Sine squared is the same as 1 minus cosine squared. Do you agree? Is that what we have here, 1 minus cosine squared? No, we have the opposite, don't we? How do I get this to be 1 cosine squared minus 1?
Oh,
How do we get it? Times negative 1, right? If I multiply both sides by negative 1, now do we have cosine squared minus 1? Ah. So we have the sine of x times, I can now replace this with negative sine squared x, which means we have negative sine cubed x. And now this is simplified. What's up, Justin?
How did you get the cube?
Because this is sine to the first times sine
Oh,
squared.
so you're multiplying.
Yeah. Yeah. Other questions? You're basically looking for ways you can substitute in your identities, okay, so that we can simplify our expression, okay? I hate to tell you, but the only way that you're going to get good at this is by practicing over and over. So this unit especially, whether you're in the homework club or not, your homework is very important, okay? The more problems you do, the better you're going to be. All right, let's look at this one. We have the sine of x plus cotangent of x times cosine of x. Okay? Last time we were able to factor out a common function. Do we have that ability right now? We do not. So we need a different strategy. Okay? Does anyone have an idea? The quotient. Okay, very good. I see a sine and a cosine, and then there's this cotangent. So maybe we could change this cotangent to what? Okay, good. Okay. So now what we have is the sine of x plus cosine squared x over sine of x. Okay? Well, we got to keep going with this. Okay, because this isn't any simpler than what we started with. So now what can we do? I've now made this one a fraction, right?
That's not really.
Okay, you want to change. Tell me what you want to do.
Not doing both over the times.
Okay, the Pythagorean identity will be helpful to us. But you are saying to add these together, we want a common denominator?
Yeah.
Okay, so what would our common denominator be? Okay, which means we need to multiply this guy by the sine of x over the sine of x, correct? Okay. We now have common denominators, right? Which means we can make one fraction out of this. Okay. So up here, I made this sine of x have a denominator of sine of x, so that's how we have sine squared over sine of x. I added them together for one fraction. Now, what do you all notice in the numerator? What is that? Okay, this is our Pythagorean identity. What is sine squared plus cosine squared? It is 1. So we have 1 over the sine of x, which is cosecant. What?
Can you go back up?
Uh-huh.
How did you get to
Okay, this is what I multiplied by so that I would have a common denominator of the sine of x. Well, right, if I had 2 plus 5/4, I would multiply 2 by 4 over 4 so that we could add them together, right? So here it's just the sine of x. Okay? You guys are all very good with algebra, and that's all this is, but we're throwing in these trig functions and identities, and so some of you are feeling uncomfortable with your algebra because it isn't what you're used to it looking like, okay? Well, like I said, the more practice you get, the better you're going to be, okay? Any other questions on this example? Okay. Okay, so we really don't like having denominators that look like this. Okay, we have 2 terms in our denominator, and it looks weird, right? So what we're going to do is we're going to multiply by something to get rid of that weird denominator. Okay. So if you recall back to last semester sometime, we worked with the word conjugate. Okay. So what we're going to do is we're going to multiply by the conjugate of this denominator. Yeah, no imaginary numbers, okay? So why did we multiply by the conjugate? Okay, well we get 1 minus sine of x upstairs. What happens when we multiply 1 plus sine of x times 1 minus sine of x? What does it get us? What happens when you multiply by conjugates?
No middle term.
The middle term goes away, so we have 1 minus sine squared x. A plus b times a minus b is a squared minus b squared. Okay, I see 1 minus sine squared. You're going to look back to your identities. Which identity should you look at? The Pythagorean. What is 1 minus sine squared? Cosine squared. Okay. All right. Now, I have a fraction with 2 terms in the numerator. Okay. When this happens, what can you do? What can I do with this fraction? Okay, we can break it into 2 pieces. I could not do that up here. We can't break up a denominator, but we can break up a numerator. So we have 1 over cosine squared minus sine of x over cosine squared. This one's not bad. What's 1 over cosine squared? Well, what's 1 over cosine? Secant. So what would 1 over cosine squared be? Okay. Now here, this is a little trickier. Okay. I have 2 cosines down here, so what we can do is we can split this up as sine of x over cosine of x, right? Because we know that's going to be something. But then we have a cosine left over. So we can write it like that. Times 1 over cosine x. Does everyone agree with how I rearranged that? Okay. So what we can write is secant squared x minus what sine over cosine? And what is 1 over cosine? Now you could factor out a secant here, but it's not going to get you anywhere. Okay, secant minus tangent isn't anything special. Alright, so we can leave it like this. Have you noticed that if we have sines and cosines, those are really easy to work with? Okay, like here everything was sines and cosines and that was easy to split apart. Okay, that can be one of your strategies if you need to change things to sines and cosines because you can't see any other way to go. Okay, that is a strategy that you can use. All right, but first you need to look for any other identities that you can substitute it. All right. Okay, let's talk about this one. I see a fraction plus a fraction. Anytime we have a fraction plus a fraction, what is our strategy? We need common denominators, right? Our common denominator is going to have to be sine times 1 plus cosine. Do you agree? We have 2 completely different denominators. They have nothing in common. So we're going to have to multiply this fraction by the sine of x over the sine of x. Right? And we're going to have to multiply this fraction by 1 plus cosine of x over 1 plus cosine of x. Right? Okay, so we have a common denominator. What is this first numerator? Sine squared. Sine times sine is sine squared. All right, this second numerator is what? Cosine plus cosine squared, correct? What do you see? Sine squared plus cosine squared is 1 because of our Pythagorean identity. So I'm going to take these two and add them together to be 1. Okay. Now what do you see? We have factors that can cancel, right? These cancel. We're left with 1 over the sine of x, which is cosecant of x. It's great, isn't it? Isn't it beautiful? We can take something so complicated and get it down to something so simple.
Isn't it still backwards too?
What's going to happen is starting tomorrow, you'll get this, and it says that it equals cosecant of x, and you're going to have to prove that it equals cosecant of x. Tomorrow actually becomes a little bit easier because you know what you're working towards. Where here, we're just simplifying until you can get simple. Okay. So tomorrow it does get a little bit better. All right. Now, one last thing before I give you your homework is the idea of trig substitution. Okay. This is a strategy used for integration in calculus, which means nothing to you right now, but it will be helpful later. Okay. So it says, hey, let x equals 2 tangent of theta, and rewrite the square root of 4 plus x squared to be in terms of theta instead. Okay? So all you're doing is substituting. Instead of the square root of 4 plus x squared, we're going to write the square root of 4 plus 2 tangent of theta squared, because that is x. Right? Can you see where this is going, maybe? Two tangent of theta squared is going to be 4 tangent squared theta. And what do you notice? What do you notice about 4 plus 4 tangent squared theta? They both have a 4, correct? So can we factor out a 4? Okay. Anytime you see a 1 added or subtracted to a function squared, you may want to look back at which identities. Pythagorean is 1 plus tangent squared, a Pythagorean identity. What does it equal? Secant squared. Okay. Well, that worked out nicely because the square root of 4 is, and the square root of secant squared? Secant. I cannot stress how important doing your homework is. Now, this looks like a lot of problems, but it's every fourth, so it's really not a lot of problems. Okay? You need to have this done tonight. We don't know when the snow is coming, so do not count on a snow day. You need to have this done this evening.
I'll be waiting till 10 o'clock and you guys are probably not going to call it. Then start your homework.
If it's not going to snow till the morning, they're not going to call it till the morning anyway, if they call it at all. So you're gonna have to be ready.
If it doesn't snow until the morning, then it's probably a better chance of being canceled because they don't have time to get all cleaned up.
But if it's only an inch, I think we all can handle an inch.
Other things, but not.
You know, no.